Assalamu alaikum students, welcome back to my YouTube channel. It's me physicswithlata. Okay, today we are going to discuss about what is the acceleration of a free fall, okay, and you can say definitely falling bodies, okay. Now we are going to see which scientist is definitely correct and which scientist has definitely given the wrong statement. Let's see. If we drop a large stone, student, do remember, if we have two objects having a large stone and a small pebble from a same height at the same time, which object will hit the ground first? I'm asking with you, student. You have been giving two things, a coin and a piece of paper. Who will come down first? Definitely this theory is related to 16th century, okay. Definitely Aristotle claimed that heavier object fell faster than a lighter object. Eventually you will also think that sir, coin will come faster, but definitely sir, a piece of paper will take much time, okay. Definitely his claim was widely accepted in 16th century. I'm talking about, student, okay. However, in the 17th century, a new scientist, Galileo, had a different findings, okay. After conducting a series of experiments, he discovered that all objects, regardless of mass or size, okay, fell at the same acceleration due to Earth's gravity. What does it mean? First scientist Aristotle claimed that heavier object will fall faster, okay, and definitely lighter object will take much time. On the other hand, Galileo predicted that no, regardless of mass, regardless of any object size, both object will come down. It means that coin and a piece of paper will come down at the same rate. Okay, let's see. We are going to see these claims of two scientists, okay, how one scientist is correct and one scientist is wrong. Okay, now Aristotle claimed, what did he say? He said that in air means definitely you have air resistance, definitely opposing force, you have a coin fall faster than a small piece of paper, okay. Now second thing, in vacuum, when we are dealing with a vacuum, student, do remember he said they fell at the same rate, okay. Now let's see, student, we are going to see that sir, the difference in air is due to the air resistance, okay. We are conducting that sir, why the heavy object will fall faster and why the lighter object will fall at the different rate. Why? Because the difference in the air is due to the air resistance. Definitely air has air resistance, some air particle definitely having a great effect on a lighter object definitely than on heavy object. It means that air resistance will have more effect on the lighter object than the weight object, or you can say heavy object, okay. The air resistance to a light body is large when compared with the body's weight, okay. With a dense piece of metal, okay, air resistance is negligible at the low speed. Student, do remember, air resistance is definitely acting more on light body than on the heavy body. Definitely there is a misconcept given by the Aristotle, okay. We are also confusing that why air resistance is not acting on the heavy body, why air resistance is acting on a lighter body. So what is the reason? We are not clear till 16th century. Student, do remember, these are the experiment done by Aristotle. Now what will happen? Now Galileo claims, now he was also assuming that definitely Aristotle was right. So he dropped a small iron ball, okay. He dropped a small iron ball, okay, number one thing, and a large cannonball, means 10 times heavier than the iron ball. He take one ball and he take the cannonball heavier than, but he was surprised that both objects fell at the same rate. It means that what have you concluded, student? One thing that basically, if I am giving you the example, student, let's suppose you are applying the weight formula, okay. Definitely this object is falling down, definitely weight is definitely towards the center, means vertically downward. mass is m, okay, and this gravity value, student, do remember gravity definitely change or value depend, okay, it can be changed, okay, gravity I will explain you, okay, it can be 10 meter per second square or 9.8 meter per second square, okay. It means that if the Galileo predicted that sir, both heavy object coin and a definitely cannon ball and a small coin fall the same rate, how do we know? Sir, weight is equal to mg. Weight, let's suppose it has a mass 50, so gravity is acting on it 1, so definitely 50 Newton. Now here, if you are seeing a small object, you have coin, you have, it has a mass of 5 kg. It means that there is a gravity acting on it 10. Yes, gravity can be changed, definitely. So it means full gravity is acting on it. That's why Galileo concept was accepted and definitely Aristotle was wrong. But definitely they were both great scientists, okay, and they have definitely improved their calculation. Now we are dealing in detail, okay, what does it mean? Now, object falling without air resistance, what does it mean, sir? Okay, you have explained that body object fall at the same rate in definitely we are talking about space. Now focus, an object can only be in free fall only be if the only force, student, acting on its own weight. It means that there is only one force acting on it, which is only its weight. Number one. Okay, the part taken by the feather, we are considering two objects, student, feather, okay, and a hammer, two objects, okay. Indefinitely, I thought about coin and a piece of paper. Now we have feather and a hammer falling in a vacuum. Always, my student, vacuum means definitely a space where there is no matter, means we are dealing with no air, okay. Do remember. Now, first of all, student, before I am going to explain these 4 points, first of all, see from the graph as well, okay. Now see, student, this is the diagram by which you can conceptually understand, student, what does it mean without air resistance, okay. Do remember. Now, at time 0 means at rest, feather, okay, is denoted with weight W, and hammer we denote with WH, okay. Now, student, now they are at rest. They are at rest. It means that there is only one force acting on it, which is weight W1 and WH, and it covers some displacement, which is S1. Okay, they both are at rest. Okay, they both are in space. Okay, in a vacuum, you can say. Okay, now see what will happen. After 1 second, student, it achieved the velocity of 10 meter per second. Means it gains. It means W1 and WH remain the same, okay, and it also covers some displacement S2, which is greater than S1. In time 2 seconds, means 1 to 2 seconds, again it gains 10 meter per second, again W1 weight and again W height of the hammer. Again displacement. Then in 3 seconds, it definitely gained 30 meter per second, constantly increasing, student, remember. It means that velocity is gaining constantly, okay, and weight of the feather means definitely, and weight of the hammer reaches at the same rate. Now, student, do remember now these points, okay. I want you to understand through graphically, through mathematically, plus you can solve through graph as well. Now, velocity of two objects undergo gravity increases, okay, by 10 meter per second at every point, means 10 meter per second, 20, 30 at each every second, okay. Number 2 point, the direction of their motion is downward, definitely it towards the center of the earth. You know that is, student, do remember, weight is always vertically downward, but it is not a good statement. Good statement is that weight is always acting toward the center, always acting toward the center, okay. Now, number 3rd point, the acceleration of free falling, okay, objects does not depend on their mass or set. You can see feather and you can see the mass of hammer. You are not going to compare the masses, but in this case free fall, definitely regardless of the masses, even though they are achieving at the same rate. See, all objects fall freely at a constant acceleration of 10 meter per second square. Okay, now we can see that this is the velocity time graph. Okay, we are going to see at 1 second it gains the velocity 10, in 2 seconds it gains the velocity 20, in 3 seconds it gains the velocity 30 meter per second. If we are going to draw this definitely uniform line, we will get the gradient, and gradient gives the acceleration. You know that sir, gradient is change in y upon change in x. Okay, and which is change in velocity upon change in time is basically acceleration. Okay student, this is the case where object falling without air resistance, and you can say object fall definitely in vacuum. Now we are dealing with object falling with air resistance. Okay, now we are dealing with real life motion. Okay, we are not dealing with space, or we are not dealing with any vacuum condition. Real life example. Okay, now when you run fast, definitely you run fast, you will feel air brushing against you. It means that you are facing air resistance. Okay, you are experience air resistance, means there is some force acting on it. Okay, it has following points. So do remember these 4 points are important. Okay, while solving these type of question, graph, non-graph question especially. Number 1, it always opposes the motion, okay, of object, of moving object. It always opposes, just like friction. If the car is definitely moving forward, okay, moving forward, you know that friction is always when two bodies are contact each other. Okay, friction will always be acting in the opposite direction to definitely reduce the speed. You definitely knew it. Okay, so always friction is the opposing force which is acting. Similar with the air resistance, is also acting against the weight. Okay, as the parachute is falling down. Okay, as the skydiver is coming down. Okay, number 2, it increases with the speed of the object. So do remember one thing, you are going to see that as the air resistance means you are going to see weight okay, is always vertically acting toward the center. Okay, and downward. And air resistance, student, this is air resistance always acting upward, so that weight and air resistance, it means that if the body is moving, it means that air resistance will also be increased. Okay, number 3, it increases with the surface area. So do remember, surface area means more air definitely come in it, definitely it can increase the air resistance. Okay, now it increases with the density of an air. I know density you will be done in 1.4 topic, but don't worry, we are covering each and every topic. Density means you are amount of mass per unit volume. Okay, so we are dealing with air density as well. So you can remember these 4 points, how object falling with air resistance. Okay, so students, motion of definitely we are dealing with piece of paper with air resistance. Okay, let's see, we are going to see the motion carefully. At time 0, student, at rest. Okay, first of all you understand R stand for air resistance. Okay, and W stand for weight of paper. Okay, now you are going to see at rest. Okay, weight and air resistance, this is weight means downward force, student, and air resistance is the upward force. Initially means 0 to 1 second, initially weight is greater than the air resistance. Okay, it covers some distance. Student, do remember one thing, that you are going to write this point as well. Okay, so when the examiner asks you about the parachute question, or they have given you the coin question, okay, so you must write these 4 to 5 5 points. Okay, initially you can say initially weight is greater than the air resistance, means downward force is greater than the upward force. Okay, now from 1 to 2 seconds, student, you are going to see again, you are going to see R2 means कि basically this R1 is smaller than R2. Why? I told you that as the speed increases, air resistance will also increase because it covers some displacement. But again, it is not equal to the weight. Let's suppose initial weight is this and air resistance we can say 10. Okay, that example. Now again we are going to see 40 weight and R2 is basically 20. Again you are going to see that air resistance is not equal to the weight. Okay, now at third case, student, you are going to see as the speed again increases, okay, it is not uniformly increased. Okay, do remember, it is not uniformly increased like a 10, 20, 30. No, it can be 10, it can be 15, it can be 25. Now here weight, again weight is equal to 40, air resistance is 30. It means that as the speed increases, air resistance means upward force is also increasing. Now at this point, student, at 4 seconds, weight is equal to the R4. It means that 40 weight is equal to the 40 air resistance. Student, do remember, means upward force, okay, is equal to the downward force. Okay, remember my words, upward force is equal to the downward force. Okay, this concept will also be enhanced once we are doing dynamics or definitely cover this topic in detail. Okay, now moving, you are going to write this for student. Do remember, now time interval. Okay, number 1, sir, forces involved. Number 3, changes in velocity and acceleration. Now displacement. Okay, now you are going to see carefully, student. At 1 means at 1 time interval, means 0 from 1, weight is greater than the R1. Definitely weight is greater than the air resistance. I told you velocity increases from 0 to V. Okay, and there is an acceleration. As you know, as the speed increases, there must be an acceleration, or it changes the direction, definitely acceleration will be produced, which I explain you. Okay, at 2 seconds, again weight is greater than the air resistance, but this air resistance is greater than the previous R1 as the speed increases. Again speed increases from V1 to V2. Now delta V smaller means that this change V2 minus V1 is definitely smaller than V1 minus V1. What does it mean? It means that as the air resistance increases, velocity increases, means upward force increases, definitely downward force means acceleration is lower in one. Okay, acceleration will be lower because as you are going to see that as the weight is 40 and air resistance is definitely now 20, so you must see that there must be force, okay, which is acting on it, and there must be acceleration which is acting towards the center is now decreasing slowly. Now at third case, student, to remember, again weight is greater than the upward resistance, but this upward distance again greater than the R2 mean 30. And okay, I'm just giving you the example 30. Now see, velocity increases, acceleration is again lower because now it will be converted to 30. Okay, upward force is now increasing. Now you are getting my point. As the upward force is increasing, downward force is gonna be reduced. Okay, now at this point, weight means 40 is equal to the air, means upward force is equal to the downward force is equal to the upward force. Are you getting my point? When the forces are balanced, student, one remember, when the forces are balanced, it means that there will be velocity stays constant. It means that body will come at the constant velocity, and change of velocity means final minus initial of velocity will remain 0. Why? Because they are now equal. It means that at this point is known as terminal. Student, do remember one point, at terminal point where the downward force and upward force are equal, where weight of the object is equal to the air resistance. Okay, then acceleration will be 0 and body will definitely move at a constant speed. This question mostly asked in the exam. I will write the definition also, don't worry, but you can conceptually understand how the piece of paper falls in definitely vacuum, and how the piece of paper fall with having air resistance. Okay. So students, we are going to see that sir, small dense object such as steel ball fall through at the same acceleration and hit the ground at the same time. Why? Because they experience low air resistance. They experience low air resistance. Okay. In comparison, a piece of paper is light, so definitely it has large surface area. It experiences greater air resistance. Okay. The paper fall at a lower acceleration. Okay. The way I explained you in the example that once you are seeing that weight, okay, we are going to see the weight is equal to mg. Okay. If we are talking about a steel ball has mass is this, gravity we are going to take 1, definitely 15 Newton. Okay. We are going to deal with the steel ball. Okay. It is just an example. Okay. Now similarly, if you are dealing with a piece of paper, student, okay, piece of paper, weight is equal to mg. Let's suppose the mass of the paper is 5 and gravity is acting on it. I told you gravity is acting on it 10. It will become 50 Newton. So you are going to see, regardless of the masses, they will achieve the constant acceleration. Okay. Now student, object experience higher air resistance when their speed increases. I told you, as the body moves downward, their air resistance is directly proportional to the velocity. As the velocity increases, air resistance is gonna be increased. So now you can understand conceptually. Now, when air resistance acting against an object equal to its weight, now do remember air resistance. Now air resistance is equal to the weight. It means that upward force is equal to the downward force. Okay. Means weight is basically this and the air resistance is acting vertically. Okay. Now what are you going to see? The object start to travel at a constant speed. Okay. Do remember, when upward and downward forces are balanced, okay, it means that it travel at a constant speed. Why? Because the resulting force is 0. Resulting force is 0. Like weight is acting 40, the upward force air resistance also 40. The 40 minus 40, you will get the resulting force 0. Now as the speed is 0, student, at this point it achieves the terminal velocity. Student, do remember, this means that object has 0 acceleration. Understood? It is that, student, if the force is 0, definitely no change in the velocity. If with the no change in the velocity, there will be no change in the acceleration. Okay. Now if an object falls through a short distance, means it can cover some distance, it may not reach terminal velocity before hitting the ground. Definitely it takes some time to reach the terminal velocity where weight and air resistance is equal. Okay. So I hope, student, your concept has been clear. Okay, when the object falls without air resistance and with air resistance in a very detailed wise. Thank you.